Welcome to today's lesson, students. So, still I am in the 9th unit of your grade 11 science textbook. We have discussed the lesson. In that, it was heat lesson. We started off the lesson with temperature, the different types of thermometers and scales used to measure temperature. Then we saw how heat transfer takes place. And we discussed the specific heat capacity of different materials. And thereafter, the expansion taking place in solids, liquids and gases when they absorb heat, and also how the heat transfer takes place in different media as well as in vacuum. That is conduction in solids, convection in liquids and gases, and thermal radiation in vacuum. And thereafter, I discuss the questions from your textbook. So now I am going to discuss some extra questions with you all. So, extra question 1. Select the most suitable answer. You are very familiar with these types of MCQ questions, multiple choice type questions. And here you are supposed to select the most suitable answer. First question, the standard unit of measuring temperature. So, you all know, students, there are different units or different scales used, the Celsius scale, Fahrenheit scale and the Kelvin scale. Out of those, the standard unit is the Kelvin scale. So, the standard unit of measuring temperature is Celsius, Fahrenheit, Kelvin, none of the above. So, although Celsius and Fahrenheit are scales, but they are not the standard unit. So, it is the Kelvin that is the standard unit. You all can remember the symbol as well. We write capital K. Then the second question. Temperature rise was observed as 30 degrees Celsius to 32 degrees Celsius. What is the change in temperature in Kelvins? So, you can remember, students, we have discussed this before. When it comes to change in temperatures, Kelvin is equal to the Celsius scale. So, what is the change in temperature here? That is theta. Final temperature minus initial temperature, that is 32 minus 30. So, it is going to be 2 degrees Celsius. That is equal to 2 Kelvins. Why? Because it is the change. Even if you convert these to Kelvins, you will have to add 273 to 32 degrees Celsius and 273 to 30 degrees Celsius, and they get cancelled off. So, the difference will be 2 Kelvins. Temperature rise was observed as 30 degrees Celsius to 32 degrees Celsius. What is the change in temperature? So, here you have to look at the question carefully. What is the change in temperature in Kelvins? It has to be 2 Kelvins. 303, that is actually equal to 30 degrees Celsius. 30 plus 273, 303. That is the initial temperature. Then 2 Kelvins is the change. 30 Kelvins, here there is no temperature relevant to 30 Kelvins, and 305 is equal to 32 degrees Celsius. 32 plus 273, you get 305 Kelvins. So, the answer is 2 Kelvins. So, with that, I will move on to the next question. The third question. Consider the statements given below. The first statement, statement A, glass mercury thermometers are used to measure high temperatures. That is correct. You all can remember the boiling point of mercury is somewhat high, above 350 degrees Celsius. So, we can use it to measure very high temperatures. And the statement B, boiling point of mercury is comparatively high. So, that is also correct. So, if we look at the answers, statements A and B are correct. That's true. And statement B explains statement A. That is also correct. Why? Because the boiling point of mercury is comparatively high only, we can use the glass mercury thermometers to measure high temperatures. Then the second answer, statements A and B are correct and statement B does not explain statement A. But it does, so it has to be the first answer. And both statements A and B are correct. That is correct, but compared to the first one, this doesn't give a full explanation. And the fourth one, both statements A and B are incorrect. That is of course wrong. So the answer is the first one. Statements A and B are correct and statement B explains statement A. Then the fourth question, freezing point of a liquid. So here it is the freezing point. You all know students, melting point and freezing points, they have the same value. Melting point is the solid becoming the liquid and the freezing point is the liquid becoming the solid. So if we look at the statements given or the answers given, temperature at which a solid turns into liquid on heating. What is that? As I told you, that is the melting point. So this is not the correct answer. Temperature at which liquid turns into vapor on heating. What is that? It is the boiling point. Boiling point. So this is melting point, then boiling point. Third answer, temperature at which a liquid turns into solid on cooling. That is freezing point. So that is the correct answer. Temperature at which a liquid turns into a solid on cooling. And the fourth answer, temperature at which a vapor turns into liquid on cooling. That process is called condensation. Condensation. So students, you all have to remember all the state changes. Melting and freezing take place at the same temperature. Boiling and condensation again occur at the same temperature. But the way the state changes is different. So here freezing point of a liquid means temperature at which a liquid turns into a solid on cooling. With that, we will move on to the next question, question number 5. Ice at 0 degrees Celsius can be converted to water vapor at 100 degrees Celsius. That you all know. If we heat ice, it will become water. First, it will melt and become water. Then, water will become hot. And thereafter, at 100 degrees Celsius, water will start to boil. And then, during boiling, water will be converted to water vapor. Within this temperature range, what are the changes that take place? A. Ice at 0 degrees Celsius turns to water at 0 degrees Celsius. That is correct. Then B. Temperature of water increases from 0 degrees Celsius to 100 degrees Celsius. That is also correct. And C. Water at 100 degrees Celsius turns to vapor at 100 degrees Celsius. That is also correct. So the first one, initially it is the melting or fusion of ice becoming water at 0 degrees Celsius. Then it is the increase in temperature, that is also correct, from 0 degrees to 100 degrees. And finally, it is boiling, the conversion of water to vapor. So all three statements are correct. A and B are correct, A and C are correct, B and C are correct, A, B and C are correct. So here all three are correct. A, B and C are correct. Then the sixth question. Incorrect statement regarding thermal radiation. So here it is the incorrect statement regarding thermal radiation. The first statement, radiated as electromagnetic waves. That is correct. Thermal radiation is a form of electromagnetic radiation, that is IR radiation. They need a medium to travel. That is incorrect because they don't need a medium to travel. Travel with the speed of light. That is correct. All the electromagnetic waves travel with the speed of light in vacuum. So that is also correct. And they can be reflected. The thermal radiation can be reflected. That is also correct. And you all can remember, students, shiny surfaces, light colored, shiny, smooth surfaces reflect radiation more compared to dark colored, rough surfaces. So they can be reflected. So the correct answer, that is the incorrect statement regarding thermal radiation, is that they need a medium to travel. So I am sure students, you also got all these answers correctly. So with that, we will move on to the next question. Question number 7. The standard international unit of heat capacity. What is heat capacity? The amount of heat required to increase the temperature of a certain substance by 1 unit temperature. So, the amount of heat per unit temperature. That is the unit of heat capacity. So, it has to be joules per degree Celsius or joules per Kelvin. But here, they have asked us to select the standard international unit of heat capacity. So, that has to be joules per Kelvin. This is the standard unit. Joules per degree Celsius, second answer, that is also correct, but that is not the standard unit. Joules per Fahrenheit, you can give it in that also, but that is not a unit that we commonly use. We don't use the Fahrenheit scale that common. And the last one, joules per kilogram per degree Celsius, that is the specific heat capacity, not heat capacity. This is specific heat capacity. So, we have selected the standard international unit of heat capacity, that is joules per Kelvin. Then the 8th one, incorrect statement. Again, incorrect statement regarding freezing point. What is freezing point? At 1 atm pressure. You all can remember, students, the melting point, boiling point, all these are calculated at 1 atmospheric pressure. At 1 atmospheric pressure, the liquid becoming solid without a change in temperature, and that temperature is known as freezing point. So, if we look at the answers, incorrect statement. Temperature at which a liquid turns into solid on cooling. That is correct. That is a correct statement. Temperature at which a liquid turns into a solid on cooling. Then the second one, the melting and freezing point of a substance have the same value. That is also correct, because when we say melting, solid becomes liquid, and when we say freezing, liquid becomes solid. And the third one, temperature at which a solid turns into a liquid on heating. So, temperature at which a solid turns into a liquid on heating is melting point. This is melting, not freezing. So, that is the incorrect statement. And finally, freezing point of water is 0 degrees Celsius. So, when we say freezing point, we have to mention the liquid. When we say melting point, we have to mention the solid. So, freezing point of water is 0 degrees Celsius. If you are going to say melting point of ice is 0 degrees Celsius. So, that is how we write. When we say freezing point, we mention the liquid. When we say melting point, we mention the solid. But they correspond to the same substance because they are all made up of H2O molecules, water molecules. So, out of these three, the first statement, second statement and the fourth one, they are all correct. The incorrect one is the third one. Temperature at which a solid turns into liquid on heating is actually melting point. But here the statement has to be regarding freezing point. So, therefore, the third one is incorrect. So, with that, students, I will move on to the next question. Question number 9. Which of the following cannot take place when a solid is heated? Cannot happen when a solid is heated. So, here the important thing is cannot take place. If we look at the answers, heat expansion. Now, when you provide heat to solid, so let's say we have a solid substance like that, you are going to provide heat, then it can undergo heat expansion. That is possible. Heat expansion, the area can increase or the length or the volume can increase. then conduction of heat can take place. From this point onwards, heat can be conducted through the solid. And especially if it is a good conductor, that will happen. But if it is an insulator, there will be no heat conduction. But here, the question is, which of the following cannot take place? This can take place. Conduction of heat can take place. And temperature can increase. Temperature increases. That also can take place. It is not a must. You all know that, students. If it is at melting point, then of course there will be no increase in temperature. Otherwise, there will be increase in temperature. So, these three are possible. Expansion, conduction and increase in temperature are all possible. Then the fourth one, specific heat capacity increases. Can that change? Specific heat capacity is a constant for a particular medium. For a particular substance, the specific heat capacity cannot change. Even if you provide heat, it will not change. But you can remember, heat capacity can change. Why? Because specific heat capacity into mass is heat capacity. So, if you have 2 kg of substance, heat capacity is a certain value. If you have 4 kg of substance, the heat capacity will be double. So, therefore, heat capacity can change, but not the specific heat capacity. So, here I can say heat capacity can change, or heat capacity changes with mass. But specific heat capacity does not change. So, that means the fourth answer. Which of the following cannot take place? Specific heat capacity increases. That cannot take place. Then we have the 10th question. Select the insulator of heat. So, you all know, students, based on the nature or the ability of a solid to conduct heat, we call them as good conductors or insulators. And normally metals are very good conductors of heat. The metal structures, the metallic lattice has the atoms that can vibrate as well as free electrons that also can vibrate and conduct heat. So, because of that, they are very good conductors of heat. But other substances like wood, plastic, wool, asbestos, all these are clay. Those are all insulators of heat. So, here we need to select the insulator of heat. Asbestos is an insulator. Now, silver is a metal, mercury is a metal, aluminium is a metal. All these are metals. They are very good conductors of heat. Metals, good conductors. So, therefore, they are not insulators. So, out of these, the insulator is asbestos. So, I am sure, students, you were also able to answer these questions correctly. And also, you remember all these information from the lesson. With that, I am going to move on to the next question. Warmness can be felt by standing near a fireplace or standing near fireplaces. Mode of heat transfer that takes place is near fireplaces, you are not in contact with fire. So, there is heat radiation, thermal radiation. Conduction takes place in solids. Convection, liquid and gas. And here it is thermal radiation or radiation. All of the above, that is also not correct. Why? For conduction to happen, you have to touch the flame. So, if it is a fireplace, you will not touch the flame. So, there is no possibility of conduction. Convection can take place if you are holding your hand above. But the most suitable mode of heat transfer will be radiation. You all can remember that. Then we have the 12th question. Which of the following is a method used to prevent heat loss by radiation from the Thermos flask? So, here In a Thermos flask, students, you all can remember there are many methods of preventing heat loss. One thing, we have the outermost covering, that is outermost case, that is made up of an insulator so that it doesn't allow heat to be conducted out into the environment. Then there is vacuum, again prevents conduction and convection. And inside there is a glass layer, glass wall that is shiny. So that prevents heat loss by radiation. And above also there is an insulator cup that prevents heat loss by convection. So all three methods of heat transfer is prevented in a Thermos flask. And heat radiation is prevented by the shiny inner surface of the wall. So if we look at the answers, there is vacuum between the inner wall and the outer wall of the Thermos flask. This will prevent conduction. So this prevents conduction. Prevents conduction by through vacuum. Prevents conduction. For conduction to take place, there should be a medium. So if it is vacuum, conduction will not take place. The lid is made up of plastic. This prevents convection. This prevents convection. Internal surface of the inner wall has a silvery shine. That is correct. And outer case is made of plastic. That again prevents conduction. This also prevents conduction. So that means the internal surface of the inner wall has a silvery shine. That is the adaptation to prevent heat loss by radiation. So that is the correct answer there. Which of the following is a method used to prevent heat loss by radiation from Thermos flask? Internal surface of the inner wall has a silvery shine. With that, I will move on to the next question. Question number 30. The standard international unit used to measure heat. So here again, standard international unit used to measure heat. Heat is the form of energy. So what is the unit? It has to be joules. If you take W, capital W, that is watts. That is used to measure the electric energy. Or this is actually power. Power of electricity. Power of electricity. Then Kelvins, yes, that is the standard international unit used to measure temperature. So this is for temperature. Then we have joules, standard international unit used to measure heat. So that is the answer, joules. And what is C? Normally we use C to indicate heat capacity or else coulombs. Coulombs is the unit used to measure charges. So here it can be either heat capacity or coulombs. Coulombs is the measure of charges. So here of course the standard international unit used to measure heat is joules because it is a form of energy, thermal energy. Then we have the 14th question. The diagram given below shows the expansion of a bimetallic strip on heating. So you all are familiar with bimetallic strips. There are two different metals riveted together and the different metals have different heat expansion. So therefore one metal expands more than the other metal. Due to that, the bimetallic strip curves on heating. So depending on the nature of the curve or depending on the metal, the way it undergoes curvature will vary. So here you can see the two metals are shown. Correct answer regarding the thermal expansion. You can see here metal A is on top and metal B is at the bottom. When it curves out, the more curvature means more heat expansion or thermal expansion. So here metal B undergoes more thermal expansion compared to metal A. So on heating, when there is thermal expansion, A has less thermal expansion than B. Why? B has a higher curvature. That means the length of the metal B is more. So expansion is more. Accordingly, if we look at the answers, metal A expands more than metal B. That is incorrect because metal B expands more. Metal A expands less than metal B. That is correct. Then we have the third answer, metals A and B expand similarly. If they show similar expansion, then of course the length will increase similarly. So there will be no curving of the bimetallic plate. None of the above. That is also not correct. So according to this diagram, metal A shows less thermal expansion compared to metal B. So the second answer, metal A expands less than metal B. That is correct. So I am sure up to now you were able to understand and answer all the questions correctly. With that, I will move on to the next question. Question number 15. Which one of the following substances have the highest boiling point? So here students, you have to find the substance with the highest boiling point. You all can remember I told you all about the relationship. If the boiling point of the substance is less than room temperature, then of course the substance will exist in the gaseous state at room temperature. Otherwise, it can be a liquid or a solid depending on the melting point. So if we look at all the answers, ethanol is a liquid. Water is a liquid. Mercury is a liquid. So these all exist in the liquid state. And iron is a solid. The question is, which one of the following substances have the highest boiling point? Now the first three, they are all in the liquid state. You can remember the boiling point of water 100 degrees Celsius. But since all these are in the liquid state, they need a certain amount of heat to reach their boiling point and thereafter for boiling. But iron is already there in the solid state. So that has to become liquid first and then it has to become a gas. That is, it has to boil thereafter. So obviously, the boiling point of iron will be greater than all the other three. So here also, you all can remember students, ethanol has the lowest boiling point. If we really write the values, ethanol, or if we consider the values, then we have water. After that, we have mercury. And then it is iron. Ethanol has the lowest boiling point, water, mercury, but all three are liquids. So obviously the boiling point of those three will be less than the boiling point of iron because the melting point of iron itself is more than room temperature. And usually you all know metals have very high melting and boiling point. Exception is mercury because the melting point of mercury is less than room temperature. That is why it is a liquid at room temperature. So you all have to remember all these concepts. You don't have to memorize the values for all these substances. Water you all know, but the others you all have to understand the concept. So according to the question, which one of the following substances have the highest boiling point? It has to be iron. Then we have the 16th question. What is the name given to the amount of heat needed to increase the temperature of 1 kilogram of iron by 1 degrees Celsius? So the amount of heat needed to increase the temperature of 1 kilogram of substance by 1 degrees Celsius. Joules per kilogram per degree Celsius. That is the unit of what? Specific heat capacity. Heat capacity, we don't consider the mass. It is the heat needed to increase the temperature by 1 unit temperature of a certain amount of substance. So here it is not heat capacity. It has to be specific heat capacity. What is latent heat of fusion? That is the third answer. The amount of heat that is absorbed when a certain amount of or when a solid substance becomes liquid on heating. The amount of heat that is absorbed is known as latent heat of fusion. And specific latent heat of fusion is the amount of heat that is absorbed by 1 kilogram of a solid substance to be converted to the same amount of liquid at its melting point. So that is specific latent heat of fusion. According to the question, what is the name given to the amount of heat needed to increase the temperature of 1 kilogram of iron by 1 degree Celsius? That is specific heat capacity. With that, students, I will move on to the next question. Question number 17. True statement regarding heat capacity. Again, here it has to be the true statement regarding heat capacity. Heat capacity doesn't depend on the nature of material. That is incorrect because it does depend on the nature of the material. So, this is incorrect. Then heat capacity of objects with different mass but made up of the same material is the same. That is also wrong. Now, let's say if you have water, you have 1 kilogram of water, and if you had 3 kilograms of water, specific heat capacity will be the same, but the heat capacity will be different. So, heat capacity of objects with different mass is the but made of the same material is the same. That is also wrong. And the third one, standard international unit of heat capacity is joule per kilogram per Kelvin. That is also incorrect. Why? Joules per kilogram per Kelvin is for specific heat capacity, not heat capacity. So, that is also incorrect. So, that means the correct statement has to be heat capacity of an object depends on its mass. That is correct. Heat capacity of an object depends on its mass. That is the fourth statement. That is the true statement from all these. Then we will move on to the 18th question. A hot piece of iron was put into a vessel containing water at room temperature. So, there is a container with water at room temperature, and here also you need to select the incorrect statement regarding the observation. The incorrect statement regarding the observation. Temperature of the piece of iron decreases. That is correct. We have done this activity, students. You can remember we have water at room temperature. You put a piece of hot iron. This is hot iron. What happens there? The iron loses heat. Water absorbs heat. So, the temperature of water increases until when? Until thermal equilibrium is reached. So, temperature of the piece of iron decreases. That is correct because it loses heat. Temperature of water increases. That is also correct. Both substances reach thermal equilibrium at one point. That is also correct. Until that point only, there will be heat transfer from iron to water. Piece of iron absorbs heat from water. That is, of course, incorrect. So, that is the answer there. A hot piece of iron was put into a vessel containing water at room temperature. Observations were made. Incorrect statement. You were supposed to select the incorrect statement regarding the observation. So that is piece of iron absorbs heat from water. That is incorrect because water absorbs heat from the piece of iron. So I am sure you were able to answer these also correctly. With that, we will move on to the next question. Question number 19. The following methods are used to boil water. So, different methods can be used to boil water. The first method is using an immersion heat. So, you all know that students, immersion heater, we immerse it completely into water. So, if you have a vessel containing water, immersion heater, the coil is inserted here. Then B is an induction cooker. In an induction cooker, there is an area like this. This is the induction part. Heat is generated by induction and directly heat is transferred to the vessel containing water. Then there is the cooker using firewood. If you have a cooker with firewood like this, the vessel will be here. The fire will be burning here. There can be lot of heat loss to the environment. This is with firewood. So then, if we look at the question. A is using an immersion heater. There all the heat is given to water because the heater is immersed inside water. When using an induction cooker, there the vessel is directly in contact with the cooker. So, it is going to be heat transfer by conduction. And then using firewood, that is also by conduction. There can be a small amount of heat transferred by convection as well as radiation, but still there is more possibility of heat loss to the environment. The most efficient method of boiling water, what is that? That is going to be this method, immersion heat, because all the heat will be given to water. Here also heat can be lost from the vessel, but here directly the heat is given to water. Once the water boils or water becomes hot, then thereafter there can be loss of heat to the environment. But the most suitable one is A. So here the most efficient method of boiling water is A only. Since they have asked most efficient. If they have asked efficient method, we can consider both A and B. Out of those, A is the most efficient method. So, we have to give the answer as A only. B only is not correct. B is electrically efficient. But here the most suitable is A. A and B only, B and C only. So, the answer is A only. Then we have the 20th question. The world's first thermometer was constructed by Isaac Newton. What is he involved with? A lot of things. You can remember the Newton's laws, the gravitational acceleration, all those are by Isaac Newton. Then Charles Darwin. We have not come across Charles Darwin. He proposed the theory of evolution. So, Isaac Newton's laws. Newton's laws and gravity. Whereas Charles Darwin, he actually proposed the law of evolution. And Galileo Galilei, he is the scientist. He is actually a scientist, philosophist, all that. So, he is the person who constructed the first thermometer, the world's first thermometer. Then Lord Kelvin, he proposed the absolute zero temperature. Absolute zero temperature. So, the world's first thermometer was constructed by Galileo Galilei. With that, students, I will move on to the next question. The absolute zero temperature in Celsius scale. The absolute zero temperature in Celsius scale. You all can remember absolute zero is 0 kelvins and that is equal to minus 273.15 degrees Celsius. That is when there is no heat energy or the mean kinetic energy of the constituent particles of a certain substance is 0. That is what we call as absolute zero temperature, and that is 0 kelvins and equal to minus 273.15 degrees Celsius. So, if you look at the answers, first answer, here they have already mentioned Celsius scale, so the unit is not given. All these are in Celsius scale. Minus 273.15, that is the absolute zero temperature. 0 degrees Celsius, the melting point of ice, freezing point of water. Then 373.15, that is a very high temperature. Minus 274.15, that is also a low temperature. This will be actually minus 1 Kelvin. So, that is not the absolute zero temperature. Absolute zero temperature is minus 273.15. Then we have the next question. Question number 22. Consider the following statements regarding black color. So, when we look at different colors, immediately you can remember the thermal radiation is related to colors. A. Absorption of thermal heat radiation is high from black color surfaces. The black colored surfaces absorb thermal radiation more. So, that statement is correct. Then we have statement B. The temperature of black colored objects usually increase more during the daytime. That is also correct. Why? During the daytime there is sunlight, so the sunlight can be absorbed by these substances. Therefore, their temperature can increase. And if they are black colored objects, the increase in temperature is usually high. If we look at the answers, A and B both are correct. That is correct. Statement A explains statement B. That is also correct. Why? Because the absorption of thermal heat radiation is high from black color surfaces, and that is the reason why during daytime when there is more sunlight, the black colored objects usually increase in temperature more. So, the first answer is correct. A and B both are correct and statement A explains statement B. Then we have the second one. A and B both are correct, but statement A does not explain statement B. That is not correct. Only statement A is correct, that is also incorrect, and both statements are incorrect, that is not the answer. So, the correct answer is A and B both are correct and statement A explains statement B. With that, students, we will move on to the next question. False statement regarding sea breeze. So, here it is the false statement that you need to select, and that also regarding sea breeze. Sea breeze, if you can remember, during the night time. Normally during the daytime what happens? There is sunlight falling on earth and the specific heat capacity of land is less than the specific heat capacity of water. So, because of that, the earth, the land becomes hot faster. The air above the land also absorbs the heat and it expands. Because of expansion, the density decreases and the air above the land rises up, creating a decrease in pressure. And to fill up that pressure or to balance that pressure, the cool air that is above sea will flow towards the land or the mass of air will move towards the land. And that is what we call as sea breeze. So usually sea breeze occurs during the daytime. But in the night time, as water takes a longer time to increase in temperature, it loses heat also very slowly. So because of that, although both land and sea cools down during the night time, land cools faster than the sea. So the air above the sea will be warm, and because of that it expands, it rises up due to the decrease in density, and the pressure of air above sea will decrease. Therefore, the cool air from land will blow towards or move towards the sea. That is what we call as land breeze. So here the question is about the false statement regarding sea breeze. Sea breeze occurs during the daytime. So if we look at the answers, first one, occurs during the daytime, that is correct. Air flows from sea towards land, that is also correct. Cause of sea breeze is the specific heat capacity of water being higher than that of the earth, that is also correct. It helps in oaring the boats during night time, that is not correct. Why? Normally night time it is the land breeze from land towards the sea, whereas sea breeze helps to bring the boat towards the land, that is during the daytime. So it helps in oaring the boats during the night time is wrong because it occurs during the daytime. So then the answer will be it helps in oaring the boats during night time, because that is not correct. It will occur during the daytime. That is the incorrect part of the answer. Then if we look at the 24th one, the mass of a piece of aluminium is 250 grams. What is the quantity of heat required to increase the temperature of the aluminium piece by 5 degrees Celsius? So here specific heat capacity of aluminium is given to you as 900 joule per kilogram per Kelvin. So students, we are familiar with the equation. If you want to calculate heat, that is Q, that is equal to mc theta. So what is m here? 250 grams. Do we use the value directly? No. We have to convert it to kilograms by dividing by 1000. So it becomes kilogram. Then what is C? Specific heat capacity, that is given to you 900 joule per kilogram per Kelvin. And then the theta is 5 degrees Celsius, that is equal to Kelvin. So we can simplify it easily. You can cancel off the units as well as the values also can be simplified. 0, 0, then the zeros here. Then we have kilogram and kilogram minus 1, Kelvin minus 1 and Kelvin. So you will get the values as 25 into 9 into 5. So when we simplify that, we will have to get the value. So if I do the calculation here, 25 into 9, 45, 22, so 225 into 5. Then we have again 5, 12, then 11. So 1125. The value has to be 1125 joules. So the mass of piece of aluminium is given to us. We need to find the quantity of heat. We have calculated it as 1125 joules. So the answers are given to us. So you all can see the first answer is given to you as 1,125,000. That is not correct. Then we have the second answer, 1125 joules. That is the correct answer. Then the next one is 112.5 joules. That is also not correct. And the last one is 45,000 joules. That is also not correct. So the answer for this, the amount of heat needed to increase the temperature of 250 grams of aluminium by 5 degrees Celsius is 1125 joules. This is the equation that you have to use, students, and you should remember we have to convert the mass into kilograms, or it has to be in the unit kilograms, and specific heat capacity and the heat capacity will be given to you. So this is how we do the calculation and get the value. So with that, I will move on to the next slide, the last question of MCQ. The change in temperature with time when ice at 0 degrees Celsius is supplied with heat is shown in the graph below. So there is ice and it is at 0 degrees Celsius, ice. So 0 degrees Celsius and they provide heat. This is how the temperature changes. So here, what is indicated by the region AB? You can see here, students, the x-axis is time in seconds, y-axis is temperature in degrees Celsius, and the values have been marked there. You can see this point to this point, the temperature remains the same. So here from point A to point B, you can see that the temperature remains the same. So what happens there? You provide heat, no change in temperature. So there will be a state change. So ice will melt and become water. That is fusion of ice or melting of ice. So the heat absorbed, what is that called? The heat that will be absorbed is what? That is the latent heat of fusion. So you can see what is indicated by the region AB. That is this part. Latent heat of vaporization of ice. Ice is a solid, so it cannot undergo vaporization. Normally, the liquids undergo vaporization at their boiling point. Then specific heat capacity of water, that is where the water absorbs heat and the temperature increases. So here it is ice and there is no increase in temperature. Then the third one, specific latent heat of fusion of ice. That is correct. Specific latent heat of fusion of ice. Although the mass is not given to us here, we know that the temperature is 0 degrees Celsius. So it has to be latent heat of fusion of ice. Since that answer is not given to us, we can select the specific latent heat of fusion of ice as the correct answer. Fourth one, specific heat capacity of ice. That is again if the ice was at a very low temperature, let's say minus 20 degrees Celsius, if you provide heat until it reaches the temperature of 0 degrees Celsius, temperature will increase and the heat absorption will depend on the specific heat capacity of ice. So there the correct answer, the answer relevant to this region AB is the specific latent heat of fusion of ice. So that is what is shown in the graph there. So I am sure, students, from all these questions, you would have understood the lesson more clearly and also you would have got the answers correctly. So with that, I am going to complete this chapter, and in the next chapter, I will be discussing more extra questions.